Hello, how you doing? So, continuously integrated Puppet in a dynamic environment. That's a terrible title. I don't know what I was thinking when it's just buzzwords, right? So, I'd say I don't know what I was thinking. I know exactly what I was thinking. I was thinking I've got an hour to get a conference proposal in, so it worked. So, it's, that's a better title for this talk. So Masterless Puppet, how and why. So we do use continuous integration as well, and we'll talk about that, but this is the real meat of the talk. So who the hell am I? I've been a Linux guy for quite some time, using Puppet for quite a while as well. I run a company in Manchester. It's in northwest England. It's where the concept of a Linux distribution was invented. We did some other stuff as well. And I run a company. I wasn't very inventive with the company name, but it did all right for Michael Dell, so, you know, that's company. So we essentially do outsourced ops for other companies. So we look after a load of different environments. So our fully managed environments are primarily transactional websites. So most of them are e-commerce retailers. Most of our customers, they really don't care how we do things. They just care that their websites are still taking money, which is nice from our point of view. The majority of our customers are on AWS. We've still got a few we haven't moved across yet, but that's the direction everybody's heading in. And the majority are using CentOS. That's just mainly to piss off the Debian devs that work for us. But yeah, so that's what we're running on. So we have some sort of key philosophies when we're developing anything and when we're deploying anything. So simple is always better than complex. And complexity is worth adding, but it's only worth adding if it provides some obvious functional benefits. Pretty much you should do the simplest thing possible. But if you're adding some reusability, so you can do the work once and then use it with multiple customers, okay, that seems like a good plan. And if you're adding resilience, well, that's absolutely a good thing because we can't really have too much downtime. Pretty much all of our customers are 24/7. They don't have periods of the day where people aren't buying things from them. Almost all of them have global customers, so there is no scheduled downtime or periods of the day when, you know what, it doesn't matter if it's down for an hour. 5 minutes downtime is a big deal for most of our customers. So, sort of an aside almost, but why did we go with AWS? And you'll probably understand more once you've seen the rest of the talk, but the feature set, and in particular the tool set, is quite a way in advance of the other cloud providers. I'm sure the others will catch up. OpenStack seems to be doing some interesting things with heat, and I think that will make it a bit more choice. But at the moment, AWS is pretty much the only way we could run in the way we do. From our customers' point of view, their main driver for going to AWS is they want to be able to scale elastically. So when we talk about elastic scaling and auto scaling, this is what we mean. So this is over the course of 24 hours. The orange area is the number of servers that we're running. So this would be on the web tier. And then the blue line, the blue area is these are requests a second that are hitting the back end, so stuff that isn't coming out of the cache. So essentially, we get more traffic. We scale up, we have more instances running, and then when you get to quieter periods of the day, that's fine, we scale back down and we run less instances. So it's a lot more efficient for our customers. They have to pay less for hosting. And also it gives them that confidence that if things go really well for them, if they get featured on a TV program or you know, they have a sudden influx of traffic for whatever reason, yeah, they can cope with that. Clearly, it's not quite as simple as just adding more web nodes at a problem, but you know, it gives them a lot of headroom. So we use a range of tools for doing what we do. We try to stick very much to the sort of the core Unix principles of do one thing and do it well. In theory, you could probably do everything that we do just using CloudFormation, you would be absolutely crazy to try. There are some examples on the Amazon website that sort of lead you into thinking, maybe I should do it all with CloudFormation. Don't, seriously. That's the wrong approach. So we have CloudFormation, which is absolutely superb when you use it for what it's really designed for. So we use that to manage our infrastructure. We use Puppet, obviously, to manage our config. And we use something called Pulp, which is a centralized repository to manage package revisions. And we use Jenkins for continuous integration, and it ties all those things together, essentially. So how we use Puppet, or how we don't use some bits of Puppet. So what we don't have is a Puppet master anywhere. We have Puppet manifests, higher data, modules. They all get distributed to all of the machines over RPM. So we build an RPM package, stick our everything in there, and then it gets pushed out to a machine. And the other thing we do about the way we work is we don't pre-bake AMIs. We actually just boot our machines with a common AMI image, so just a standard CentOS AMI image, which we make publicly available. And when our machines boot, they get configured at boot time. So Puppet runs, the magic happens, and it's serving. So what's wrong with a Puppet master? Why don't we use a Puppet master? Well, it comes down to this concept of pets versus cattle. So I don't know if you've seen this. I think it's been talked about in quite a few other talks. I think it's a guy at CERN that was first talking about this. So there are essentially two approaches to servers. You can think of your servers as pets. You give them nice, fluffy names. And if it gets sick, you nurse it back to health. But that's not the world that we live in. The world we live in, our servers are cattle. Okay, they scale up when we need them, and if there's more than is economically viable, we just take them out the back and shoot them. We don't want them. So Puppet is very much designed for servers as pets, which I think is entirely reasonable, because when Puppet was initially conceived and when they started writing it, that's how all servers were. There wasn't really a concept of servers as auto-scaling cattle. But for the way we work, those assumptions can work against us, and they can work against us quite heavily. So we're just going to go through some of the thought processes behind why we decided to go down this route, and then we'll look at how we actually do that. So the first thing we come up against is, out the box, Puppet expects you to manually sign certificates. Clearly, that just isn't going to fly for us. We have servers that come up because an alarm happened in CloudWatch, and that alarm happened because we had lots of traffic. We don't want to have someone go on a machine and sign a certificate. So, well, there are things we could do about that. This is not an insurmountable problem. We could just turn auto sign on and say, yeah, right, just sign whatever certificates you get. Or maybe we could be a bit more clever, in inverted commas, and maybe we could write or use, if there is one already, some sort of automated certificate generation mechanism and tie it in with auto-scaling. So maybe we could have auto-scaling, fire an event that says, oh, I'm going to bring a new server up, and then it takes a message off the queue and makes a certificate and somehow gets it on this new machine and on the Puppet master. And we could maybe have done something like that. It sounds like a bit too much like hard work, but we could have done that. There's no mechanism by default in cleaning up old hosts. That's a big problem for us because we often get reused host names. So you're just going to get Puppet say, you know what, I've seen you before, I've seen this host name before, and it's not that certificate you've just presented me, so I'm not going to give you any config at all. Clearly, that's not a situation you want to be in. Plus, you're just going to get a disk full of old certificates that belong to a machine that was running for a few hours, maybe a day or two, and no longer exists at all. So there are some workarounds. We could use UUID certificates, so that's been supported in Puppet for a while. We could just agree, look, we're not going to look in the Puppet directory at all these old certificates. Or we could write a mechanism for cleaning up the old certificates. That would work too, I suppose. But okay, this is more work we'd have to do. And then the next thing, so Puppet configures machines based on their host name. Our machines have host names like IP and the IP address. How does Puppet know what type of machine that is? It doesn't, is the answer. So we could use an external node classifier. So I actually played around with this. I wrote a little bash script using NC that worked as an external node classifier. And we had something, just bare bones prototype working. But then I realized, hey, this is way more work than we should be doing because, simple is almost always better. The simpler way would be just, instead of our machines being called IP-something, we just prefix the machine type in the host name. So we call it web-something, and we just have a regex match to match that. So I don't know if any of you were in the Obama for America talk earlier. I think the guy was saying that's the way they did it, which, yeah, that seems like a reasonable approach. But this one's the real killer for us. Puppet Master is a single point of failure. If there's no Puppet Master, we can't scale up. And that's a big problem for us. And that's especially a problem because of the way Amazon works. So Amazon has lots of availability zones. What an availability zone actually is a data center. So when we provision infrastructure for customers, we provision it across multiple availability zones, so across multiple data centers. And Amazon in their SLA say, we guarantee that no more than one of those data centers will fail at once. So, okay, we have to assume that there may be one of those down at any time. Actually, it's pretty rare for an availability zone to go out, but we have to plan for that eventuality. So imagine we've got a Puppet Master in a zone, and we've got some web nodes in that same zone, and the whole zone goes down. We're screwed, because we've just lost a load of capacity, and we've also lost our ability to add any new nodes to replace the failed ones. So this is this was the real driver for us to not have a Puppet Master. But there were workarounds we could have done. So we could have clustered Puppet somehow. There are plenty of people doing it. It's not an impossible thing to do. Again, it seemed like more work than we wanted to do. And it just, here's a list of all the workarounds we've got to so far. And I'm sure there were other things we would have had to work around as well. So we would have had to write, or maybe use, if there is one out there, we didn't find one at the time, a certificate management software. We would have had to write an external node classifier, or just have a way of setting the host name appropriately so it's got the role of the machine. And we would have had to cluster multiple Puppet Masters. So we just thought, yeah, that's way too much work. We don't want to do that. So we just decided, you know what, Puppet Master, it's a square peg in a round hole. And all we're trying to do with all those workarounds is just sort of chop bits off the side and shave it a bit here and there and get it through that hole. Let's just not use it at all. And actually, it's really easy to use Puppet without a Puppet Master. That's all you need to do. Puppet, apply, module path, etc. modules, the Puppet manifest, that's it, done. Cool. Except it's not quite that easy, because it never is, right? So you've got to get those manifests onto your machine somehow. And remember, we boot our machines completely bare. They have nothing on them at all other than just a bare CentOS image. And one other thing that we'll talk about later. So how do we distribute it? Well, we pack them into RPMs, of course. Why would you do anything different? So we distribute a full set of manifests, modules, to each machine. That's actually generic for all machines across an infrastructure. We could have done a bit more work and made it so we had different RPMs for different types of machines. We did some things that meant that we didn't think that was necessary. And again, simpler you can have it, the better. So we tried to keep it as simple as possible. But obviously, we only apply the manifest that's relevant to the particular machine. So it might have a load of modules that it just doesn't use on that particular machine. We're fine with that. So how do we pack manifests into an RPM? Well, fundamentally, all we do is we have an RPM that contains the contents of the etc. Puppet directory. And we do something a bit different. We make it readable only by root. Because we're running the Puppet apply as root, there's absolutely no need for any other user to be able to read these Puppet manifests. So we try to enhance the security a bit by doing that. So how do we actually apply the Puppet manifests? I know Reinhardt that spoke this morning and nicely name-checked me. They're doing stuff with Fabric, I think, to apply the Puppet manifests. We just do it on RPM install. So we just have a post-inst command that does a Puppet apply, except it does a bit more than a Puppet apply, because the problem we found is, well, we install the Puppet package through yum. So we install the Puppet package, and then the Puppet package runs the post-inst, but we're still inside yum, and Puppet manifests basically always are going to be installing new packages. So we can't install packages without starting up another copy of yum. You can only have one copy of yum running at a time, and just basically the whole thing just stops. So that wasn't a goer. So we have a bit of a dirty hack workaround, which is that, there we are. We have an @ script that just says @now plus 1 minute, check to see if yum's still running. And if it isn't, do the Puppet apply. If anyone's got any suggestions on a cleaner way to do that, I'm very happy to hear it. We have been running it this way for 18 months. We've never had a problem with it, but it's one of those things you think, I'm sure there's a better way to do it than this, but you know what? It works. So we've got some RPMs. We've got RPMs that you install them, and it applies the actual Puppet config, which is cool. But we've got to get those RPMs onto our machines. So how do we do that? So Pulp. We were already using Pulp. So it was the obvious solution for us to deploy these packages. So what is Pulp? It's Yum repository management. It's written by the guys at Red Hat. I think it's part of their replacement for Satellite, which if you've ever used Satellite, God, it needs some serious replacement. It's a really nice piece of software, actually. We were using it already for managing security updates and also for deploying application code. So yeah, it's repository manager. Gives us a mechanism for easily auditing what packages and versions we have. So we can just say, OK, we know there's a vulnerability in HTTPD. Just tell me every machine that has HTTPD installed, please, and what version it has. So it'll give us that, and we can then push out a new version of that package to all the relevant machines. So it uses message queuing. It's not actually very dissimilar to mcollective, but it's completely different. And it has this concept of content distribution servers for easy replication. So that was a big plus for us. So we can just say, right, we've got a CDS over here. So that just mirrors everything. So we've got a copy of all the packages in multiple availability zones. So each of our nodes speaks to the repository in its own availability zone. So if we have an availability zone go out, OK, no problem. The other machines in the other availability zones can come up and read from their local Pulp content distribution servers. And if it's just a content distribution server that goes out, OK, we can't spin up any new nodes in that availability zone, but that's not a big deal. We have the content distribution servers auto-scale back, so they're sort of self-healing, depending on the failure mode. So we essentially split out roles. Remember I said before, do one thing, do it well. So Puppet, we used to say what packages should be installed on a system. We need a web server, so it should have HTTPD and mod.php or whatever is relevant for the particular infrastructure. And then we use Pulp to manage which version. So, right, we need this version of the HTTPD package, and we need this version of the actual web software that's being served up. Pulp gives us some nice extra features as well. So it allows us to clone repos and copy packages between repos. So we use that to go from like a QA environment to a staging server and then push it out to production. So that's nice. It helps us with our workflow there. So we can do the same thing with Puppet configs, and we can do the same thing with security updates. So everything just goes through this same process of going through a QA server, a stage server, onto prod. Yeah, works nicely for us. So we're pretty much just deploying Puppet configs in the exact same way we deploy code, and the same way we deploy security updates. We deploy everything in the same way. So we've actually removed a lot of complexity from our system, which is great because simple is better. So we're already deploying code from Jenkins, so we thought, well, let's do the same with Puppet. So how do we deploy code? So we use Jenkins. Everyone here familiar with Jenkins? Show of hands for Jenkins, guys. Okay, good. That's a strong show of hands. So we have Jenkins build RPMs, and then we have it trigger Pulp to actually install those RPMs on the relevant remote machines. So the workflow is essentially stuff gets checked into Git, Jenkins pulls it out from Git, an RPM gets built, some tests get run. As long as the tests are all okay, RPM gets added to the relevant machines. And we manage the deployment lifecycle from Jenkins. So we use RPMs on staging. We use this Jenkins plugin, because Jenkins has about 1 million plugins, right? So we use the promoted builds plugin to then say, okay, that RPM we built for the staging machine, deploy that same RPM onto the live infrastructure. And that's something that a developer can do, literally at the click of a button. So you click, yep, approve, and it just gets installed. So our Puppet deployment process is pretty much the same. We check our Puppet manifest into Git, which I'm sure you're all doing anyway, right? We lint, we're using Puppet lint with the Jenkins warnings plugin. We actually don't check our modules into Git. We only check the manifest into Git. And then we have separate Git repos for our custom modules. And we use librarian Puppet. So where we've got modules that are on the Forge or they're on GitHub, we have a librarian Puppet file that basically says, yeah, here's a list of all the modules we've got. The nice thing about that is that handles dependencies for us as well. So if a module says, oh, I actually need all these other modules, so like probably concat and standard lib, almost all modules need those. It will just handle putting those down. It all gets packed into one RPM, and then we can deploy that. We did actually look at packing modules into separate RPMs. It's technically absolutely feasible. Wouldn't be a huge amount of work, but it seemed to us like more work than was necessary given the minimal extra benefit. But yeah, it might be a fun thing to do, and then you could have proper RPM dependencies between these things. I'm not sure it would actually give us enough benefit that it would be worth doing. And then the final thing we do with our Puppet deployment process is we run the exact same functional tests that we run on the code base. So we have something that tests the code base. So often they're Selenium tests or WebDriver or whatever it is these days that are testing the actual application code. So we're spinning up a whole raft of application servers. So we'll spin up essentially a complete copy of the stack. Puppet does its thing, configures all the servers, and then the functional tests get run. So we're testing that the application is still working even after the changes we made in Puppet. We don't actually run any of the RSpec tests and the other things that are provided in Puppet. I think we could do that. The workflow is sort of, okay, you check into the modules are into a separate repo, and at the point at which they're checked into the repo, that's really the point at which the modules themselves should be tested. So at this point, we're just doing functional tests to ensure that the system as a whole is working, not any individual module. So putting it into production, once you've done suitable tests, and generally we have just manual, let's go and sanity check that the thing that we changed has actually been changed like we thought it was going to be. We promote the Puppet config into production. And again, we use Jenkins promoted build. So that's the output of a successful promotion to staging. So it tells us, right, okay, we promoted it 4 days, 19 hours ago. We know, right, that's on staging. We know who put it there as well, which is a nice extra thing we get. So yeah, it's a nice workflow. It's a really visible workflow to everyone within the organization, which is especially important for us because we're managing a number of disparate infrastructures. So you might be asked to do some work on something that, hey, I've not seen this infrastructure for a couple of months. So you need to know, okay, well, what's been going on? You can see easily what's been going on, obviously through the Git history, but also through, well, what's actually been making it into production. So if you've been following along, you're probably thinking, hang on, there's a few things this guy hasn't told me yet. So I still haven't really covered how do we actually get from a bare metal machine that just all it has is just a copy of CentOS to an actual state where Pulp can push a package to it. And we still haven't covered, well, how does the machine know what it is? And obviously there are various things we need to do. So we need to find other machines. So if you've got a web application, pretty much always it needs to speak to some kind of database. How do we find these other resources? So that's where CloudFormation comes in. So it's a very nice Amazon tool for specifying infrastructure. I say that as someone whose last talk was why I hate CloudFormation. So it has its foibles, but it's absolutely the least worst tool for this type of thing. So pretty much everything we provision inside AWS is provisioned via CloudFormation. I say pretty much everything because Amazon don't actually give you everything in CloudFormation. Laziness, probably, I don't know. But they're generally pretty minor things. Like you can't create a domain name itself, but you can add resource records to a domain. But how often are you creating a new domain name? Well, pretty infrequently. You can probably live without that being done inside a CloudFormation template anyway. And a CloudFormation template is it's a JSON file, which is great. So again, we can check it into Git, and we've got that complete audit history. So not only have we got an audit history of our configuration on our machine stored in Git, we've got an audit history of our entire infrastructure in Git. So if you've made a firewall rule change or a security group, as it's called in Amazon world, that's checked into Git. You can see exactly what was done. If someone's added a new route, down a VPN or something, yeah, no problem. You can see it, it's checked into Git. Someone's added a new machine, yep, checked into Git. Change the machine type, it's in Git. Basically, all you ever need to do is have a look at Git log. You can see exactly what's been going on with an infrastructure. That's the main reason I think CloudFormation is such a game changer. So, CloudInit. CloudInit is actually, I think, originally an Ubuntu project, but it's basically standard on AWS. So if you use the Amazon Linux distribution on AWS, then it has CloudInit. The CentOS images that we provide, the only difference between standard CentOS and our images is they ship with CloudInit enabled. CloudInit is really handy. So it sorts out things like SSH keys. So obviously you need to have new SSH keys. And also, in Amazon land, we specify, here's an SSH key that I'm going to log in as. Obviously, we have Puppet add users and SSH keys as well. But prior to that point, if Puppet isn't running, you need a way of getting into the machine. CloudInit is adding the relevant SSH keys that we've specified via the Amazon API via CloudFormation. And importantly, it allows us to provide a bash script to run at startup. So, hey presto, we've solved all our problems. So, CloudInit automatically manually, so it's doing it automatically, but it's basically just writing a file into etc. yum repos.d, or yeah, whatever the directory is called. That contains our Pulp, Puppet, and our Puppet manifests repositories, and then installs the appropriate RPMs. And from then on, Puppet runs. We have a Puppet module which subscribes the machine to what they call consumer groups in Pulp. So it's getting the right type of files. And then Puppet runs in the normal way. So it pulls down the packages. It happens to be pulling them down from Pulp, but it's just a YUM provider, and it's just fetching them over HTTP, or HTTPS, actually. So we don't need to worry too much about that. That's essentially all handled for us. So how does the machine know what type of machine it is? Well, because we tell it. And we tell it in the CloudFormation template. So in the CloudFormation template, what we're doing is we write a file to disk that we can just source in Bash. So we just do puppet apply, module path, whatever, $host type. And $host type got set in this file that we created from the shell script that got run when the machine started up. Yeah, that's all we had to do. We had to source it. So again, going back to, I don't know how many of you were at the previous Obama for America talk, but the guy there was saying, oh, so we do this thing where we were putting these details into an S3 bucket, I think, and then they were using roles and pulling it out. That sounds way too complex for me. That sounds too much like hard work. So we just do it this way. It works great. And we need extra facts. So Factor gives some easy ways of providing extra facts. Actually, there's an arguably better way now, but we've been running this for 18 months, so the better way doesn't exist. So in the same file that we sourced before we run Puppet apply, we have factor underscore host environment equals live. So if you typed factor host environment, you'd get the response live. And factor stack name, so that's the CloudFormation stack name, customer-web-live. So, okay, we know that's the stack name, and we can do things with that in our Puppet manifests if we need to. These days, you can put in etc. factor facts.d a file. So we could create a file called stack name, and the contents would be customer-web-live, and the same thing would happen. You type factor stack name, and you'd get the same response. It didn't exist when we did it like this. I don't see any compelling reason to change it. We've also seen there's this nice project on GitHub that we haven't really looked at yet, but it's on our radar. It's on our list of things to look at. Hira CloudFormation. So we could pull Hira data out of CloudFormation. That sounds kind of cool. Maybe would be too complex for us because we like to keep it simple. But yeah, it could be interesting. So, and we also provide other details in the exact same way. And this is essentially how we mitigate the problem of we're deploying all the manifests and all the modules to every machine. So things like database passwords, clearly we don't want every machine to have the database passwords that are used. So we set that as a factor fact. I suppose these days we could set it via Hira, but it works with Factor. I don't see, again, any compelling reason to change. So it's only available on the right machine, and you have to be root to read the environment file anyway. That seems like a good mitigation strategy to us. And then other things, we just discover it by looking at the EC2 API. So Varnish servers, for example, we sort of had this idea, maybe, because you can use, without a Puppet master, you can still use stored configs. I don't know if it's still called stored configs, PuppetDB. So you can put, the @@ in and pull stuff out that other machines have set. This idea that, okay, right, we still need to have a stored config server, but then we're going to have to cluster Postgres, except it's not even using Postgres in stored configs anymore. We just thought, you know what, actually there's a much easier way. We just call the EC2 API, say, yeah, just give me a list of all the live web nodes, and we just put that data into Varnish. So that works really, really simply and really effectively. So 3 wins. We got a load of stuff when we did this that it wasn't why we did it, and most of them, we didn't even realize we were going to get it until after we'd put it into production, and actually, whoa, this stuff's really handy. So some of the things we did, we obviously get much better control over the timing of Puppet runs. So previously, you're running Puppet Master, you check something into Git, merge it into the live environment, and then, yeah, within 30 minutes, you'll have your config everywhere. Well, okay, that's okay, but we do it this way. You click approve in Jenkins, and pretty quickly, within a minute or two, it's on all your nodes. Great, okay, that's good. It gives everyone a lot better visibility of what's going on with the system. So if you're a dev, you may or may not have access to our Puppet Git repo. But even if you have access to it, in my experience, you're probably not actually looking at what we've done. But it's really simple for you to just go into Jenkins and see, well, what's been changed recently? Something's broken on my app. Is it my fault? Well, yeah, probably. You're the dev. Or is it the sysadmins that have broken it? And it avoids a lot of arguments that could otherwise crop up. Yeah, and it enforces that configuration changes have to be deployed to the testing staging environment anyway. Obviously, we were always doing that anyway, but previously, you got a branch which is master in Git. You could accidentally commit something to master and, oh, I've just configured all my servers to power off. So if you do that now, you're only powering off the testing environment. That's not such a big deal. So it's enforcing that control, and there is absolutely no way, without really trying, to get something into live without first going through the proper testing process. So that's cool, and we got that for free. And we've got some other things as well. So our Puppet configs have a version number. So Jenkins just has a number. It's just like every time it builds a new package, it increments a counter. So our Puppet configs have a version, which is great, because you can say, OK, so we've got this version on staging. We've got this version on live. There's no question about, well, what's the difference? Have these machines got the same config, or have they got a different config? Well, they've got a version. You can see if they've got the same version number. And you can also get a good idea of, well, we've got a load of changes here that have gotten as far as staging, but for some reason, nobody's pushed these live. So, there's obviously something going wrong here. And config changelogs are available on every machine, which is handy when you're logged into a machine, you're trying to diagnose an issue, typically on testing or staging, but maybe on live if you've got one of these 4 a.m. issues. We add the Git changelog to the RPM changelog, so you can just see, OK, right, that's what the last change was. You could sort of do that with Git, but it's a lot easier to correlate things. But, of course, there's some downsides to running the way we run. So, like I said before, we've got all our modules, all our manifests on every machine. I don't see that as a huge issue. If someone can, you've got to be root on a machine on the infrastructure to be able to see these things. And if someone can see our varnish configs on a web node, we've probably got bigger problems than worrying about you being able to see the varnish config. And we mitigate it by having CloudFormation holding the most sensitive data. So there's a few ways we could do the same thing, but without using Pulp. I guess that there's probably a lot of people here that almost certainly the vast majority of you aren't using Pulp already, like we were. You could do the same thing with a Yum S3 plugin. So this is a really neat plugin. You can just create an S3 bucket. And you can use the AWS IAM roles to pull the Yum packages, pull the RPM packages out using Yum. So you just type Yum install, and you don't have to worry about it's going away to S3, fetching it, pulling it back. And then you could use mcollective to push out the package updates. So there's a few ways you could do essentially the same thing. One of the improvements we're looking at, I don't know how many of you came to Mitchell Hashimoto's talk yesterday on Packer. Mitchell's the Vagrant guy. I bet he loves being called that. The guy that made Vagrant. So his new thing is Packer, and it allows you to build machine images really easily. So one of the things we're looking at is, well, we could use Packer to actually make machine images. So instead of building an RPM, pushing it out to these machines, we could build an RPM and use Packer to make a machine image. The driver for that is it decreases the amount of time it would take to auto-scale. So at the moment, it's about 6 to 8 minutes from the point at which CloudWatch sees, well, OK, we're getting a bit heavy on load here. We need to spin up some more instances to the time those instances are actually available, which, that's pretty good. That's generally fine for us. But if we can speed that up, that would be a good thing. The way we've implemented things, with the variables and things are different for different machines. We'd probably still need to run Puppet at boot, but that Puppet run's going to take a lot less time because it doesn't need to pull in all the packages, and it doesn't need to configure everything. It just needs to probably configure one or two things that are different. So maybe you're looking at a different Gluster node, maybe looking at a different database because you're in staging, you're not in QA, that type of thing. So, questions, comments, abuse? Anyone? With a microphone over here, I think.
Yeah. So, I have one question for you. So, you seem to do the RPM versioning for the modules sequentially, right?
Yep.
But what if you have two developers working on separate features independently, and you need to package and distribute and deploy, see if it works? So you have feature A and feature B. How does that work in your environment?
Okay, so our RPMs don't get built until the point at which they're ready to go onto the QA infrastructure. So at that point, Jenkins builds them. Prior to that, they would be in their own separate feature branch, and we would just be using, the sysadmin would just be using their local Vagrant instances to test that. So there isn't an overlap because essentially the point at which you merge the feature in, the package gets built. You're right in that, yeah, there is sometimes an overlap. So, I had a feature, someone else adds a feature. Now they're both on QA. They've both got to be tested. But, actually that's pretty okay because we're testing the system as a whole is functional. That's fine. We've added overlapping features. That's not a problem. You're not merging to QA until you're ready to go, essentially, anyway.
Okay, and then one more question. So you have some older hosts running a certain version, and then you're deploying new hosts with your latest version of your modules. So do you ever have to maintain a legacy branch for any reason, or you can always work at the top level of all your
So sorry, just to clarify, so you're asking about when we pull in the modules with librarian?
Right. So maybe you have these. Sorry. So you have an older version of some program, version 1, and then you have something version 2. So you might have two clusters running. Do you use Pulp to differentiate which repo has the right RPM with the modules, or do you always go to the newest? You don't install any old versions?
So the answer is in the librarian config, we're saying, use this version of the module, and then periodically we'll upgrade that version essentially.
Okay, so you rely on librarian. Okay, thanks.
I have a question right here.
Yep.
I kind of also have like a big love-hate relationship with CloudFormation. I think it's really powerful. It's really cool. You can do lots of stuff, but the JSON syntax is horrible. But okay, you could get over this. But one thing I really either want Amazon to work on, or you guys, I don't know. It's like testing CloudFormation templates. There is no real way of doing it. It's live, you're paying for it, and if it crashes in the end, there you go, and start over. Do you guys have any, is there a way of handling it?
Okay. So there's essentially two parts to that question.
Yeah.
How do we test the CloudFormation templates?
Yeah.
And then
or changes to it.
Yeah. So what we would really, really like Amazon to introduce, and we have said this to them very frequently, is like a no-op mode.
Yeah,
like you have like Puppet apply, no-op. We would absolutely love that in CloudFormation. Maybe it's on a roadmap somewhere, but Amazon haven't told us. So that would be great. We work around some of the problems with CloudFormation. We make it a bit easier with essentially we use CPP and make files so that we can hash include things within the template, and also so we can add comments.
Yeah, that's a big not a big biggie. Yeah, the comments.
Yeah. So we make things a bit easier that way. But yeah, that's probably time for an AWS talk.
Okay, thanks.
I had a question. How do you prevent unauthorized hosts from downloading and installing your Puppet configs?
So everything that we provision is in what Amazon call Virtual Private Cloud, VPC. So we have internal IP addresses. The Pulp master, as we call it, only listens, it only has an internal IP. And then we have Amazon security group. So a security group is essentially a firewall around each and every machine within the infrastructure. So we have that as well as a mechanism for saying you're only going to accept connections from machines that are on the internal network.
Okay. Thanks.
Okay. No more? Okay, thanks everyone.